Hello everyone, welcome back to our channel CSPictorial. This video is about a few important multiple choice questions in Boolean Algebra. Please don't skip and watch this video until the end if you are preparing for any competitive exams. Please check our course of Boolean Algebra in our channel. It will surely help you understand Boolean Algebra concepts from very basic definitions. Which of the following is a functionally complete set of gates? NAND, NOT. The answer is option A, first but not the second. That is, only NAND gate is functionally complete set of gates. In digital electronics, functional completeness means that every possible logic gate can be constructed using gates given in the set. Accordingly, all logic gates can be assembled from either only binary NAND gates or only binary NOR gates. Thereby, NAND are functionally complete set of gates. Simplify the expression y equal to AB bar C plus AB bar C bar. The answer is option D, y equal to AB bar. The expression is solved in two simple steps. We take out the common term AB bar and write C plus C bar within the brackets. Now, according to Boolean law, C plus C bar becomes 1 and anything multiplied by 1 will be the term itself. So, AB bar into 1 becomes AB bar, the simplified expression. Simplified expressions for the following Boolean function. The simplified expressions and the options are given to choose. The given expression may have one or even two simplified forms. The answer is option D, second and fourth only. Let's find out the solution. We use Karnaugh map to solve the given Boolean expression. Since a summation sign is given, we understand that the terms in the expression are main terms. So, we place ones in the order as mentioned in the expression. Always remember the order of placing ones in a Karnaugh map. Now, it's the next step of grouping. Check our previous video about K-map grouping rules for clear understanding. First, we make this quad. This cancels out the terms D, D bar. Again, one more D, D bar gets cancelled. Then, C, C bar and again C, C bar get cancelled, leaving the term A bar, B bar in the final expression. We make one more quad like this. This cancels out again D, D bar, C, C bar twice, leaving the term A, B in the final expression. This pair cancels out B, B bar, leaving A bar, C, D bar. Here is where the difference comes. We can make a pair the other way, leaving the term B, C, D bar. So we can get two simplified expressions, F equal to A bar B bar plus AB plus A bar C D bar, and also another simplified expression as F equal to A bar B bar plus AB plus B C D bar. The logical sum of two or more logical product terms is SOP, POS, NOR, NAND. The answer is option A, SOP. SOP stands for sum of products. Which of the following expressions is in sum of products form? A plus B into C plus D, A into B into CD, AB into CD, AB plus CD. The answer is option D, AB plus CD. The expression AB plus CD has summed up two product terms. AB is a product term and CD is another product term. So, it is the sum of products, that is SOP expression. The Boolean function with the given Karnaugh map is, the options are given. The answer is option A plus C into D plus B. First, we make the largest possible group an octet. This octet cancels out the terms A bar, C bar and D bar, leaving B in the final expression. Then we make this quad, leaving the term AD. Then this quad gives the term CD. This expression could still be simplified as B plus D into A plus C, which is again equal to A plus C into D plus B. So we get the answer F equal to A plus C into D plus B. The Boolean expression a bar dot b plus a dot b bar plus a dot b is equivalent to. The options are given. The answer is option D, a plus b. These are the steps for simplification. First, take out the common term a and include b plus b bar within brackets. Now, according to complement law, b plus b bar becomes 1. So, we get the expression a bar dot b plus a. Applying Boolean laws, the expression is written as a bar plus a into a plus b. Again, the complement law makes a bar plus a equals 1. So, we get the final simplified expression a plus b. Kindly check our previous videos about Boolean laws and simplification procedure of Boolean expression using Boolean laws for better understanding. From the given truth table, determine the standard sum of products expression. The answer is option D, x equal to a bar b bar c plus a bar b c plus a b c bar. Let's check out how to derive it. From the given truth table, pick out the truth table entries for which the output value is 1. Write the corresponding main term. In the first entry, A is 0, B is 0 and C is 1. So, the main term is written as A bar, B bar, C. Remember, if the value of the variable is 1, write the literal as such, and if the value of the variable is 0, write the complement of the literal in its min term. Check our previous video about canonical and standard SOP for a clear understanding from the scratch. Now, other min terms are similarly written as A bar BC and A B C bar. Finally, the SOP expression is derived by summing up all the min terms. We get the SOP expression as A bar B bar C plus A bar BC plus A B C bar. Convert the given SOP expression into an equivalent POS expression. The answer is option B, A plus B plus C into A plus B bar plus C into A plus B bar plus C bar. Let's check out how it's done. This is solved in 2 steps. First, use the truth table to enter the given min terms. Here, for the first product term A, B, C, the input values are A equal to 1, B equal to 1 and C equal to 1. Enter 1 in the corresponding truth table entry. Similarly, for the second product term A, B bar, C bar, the input values are A equals 1, B equals 0 and C equals 0. Make an entry 1 in the corresponding output value F. Repeat the same for the terms A, B bar, C plus A, B, C bar plus A bar B bar C. Here we actually need the max terms as the question is to find the POS expression. Thereby the terms not present in min term representation become the max terms. So enter 0 in the truth table output F for all the max terms. Now to derive the max term, always remember for POS, if the value of the input variable is 0, write the literal as such in the max term, and if the value of the input variable is 1, the max term will have the complement of the literal. In the first entry, A is equal to 0, B is equal to 0 and C is 0. The max term is written as A plus B plus C. In the second entry, A equal to 0, B equal to 1 and C equal to 0. So the max term is written as A plus B bar plus C. And in the third entry, A is 0, B is 1 and C is 1. So the max term is written as A plus B bar plus C bar. Finally, we derive the POS expression by multiplying all the max terms. F equal to A plus B plus C into A plus B bar plus C into A plus B bar plus C bar. Check our previous video for more such conversion problems. Simplify using K-map. The answer is option A, B D plus B bar D bar. Let's check out the solution steps. As we could observe from the question that the given Boolean function has minterms, put ones in blocks of K-map respective to the minterms. Do not forget the order in which the K-map cells are to be filled. It follows the gray code sequence. It is always a better practice to first number out the cells as shown here, then fill up the cells. In this example, place 1 in the cells numbered 0, 2, 5, 7, 8, 10, 13 and 15. It is optional to fill the remaining cells with 0. Make groups with total terms in powers of 2, trying to cover as many elements as possible in a single group. A detailed video about the rules for grouping of cells in K-map is available in our channel. Please check that video. It will surely help you understand the step. Here we have the squad group of 4 ones. Then we try making another group by wrapping around the table. Thereby we get another quad. From the groups created, find the product terms and then sum them up for the SOP expression. Let us first consider this group. Note the corresponding Boolean terms. This group points to terms A bar B, AB and C bar D. CD. K-map works on the basis of complement laws. Here A and A bar, C and C bar get cancelled and the terms B, D get into the final simplified expression. Similarly, the next group points to the terms A bar, B bar, A, B bar, C bar, D bar and C, D bar. Here A bar and C, C bar get cancelled, making B bar, D bar get into the final simplified expression. Finally, the simplified expression is BD plus B bar, D bar. Simplify using K-map. The answer is option B, A plus B bar D bar plus B bar C bar. Let's find out the solution steps. The given Boolean function specifies the minterms and the don't cares denoted as D terms. First of all, fill up ones in the blocks of K-map respective to the minterms and place X in the blocks respective to don't care. Try making larger groups. Include don't care cells wherever possible. We get this octet only after involving the don't care cell. This group points to AB bar, C bar, D bar, C bar, D, CD and CD bar. Here B bar, D bar, C bar and one more C bar get cancelled, leaving the term A in the final simplified expression. Then we make another quad and get the term B bar C bar. Finally, we get the next quad by wrapping around the table involving the don't care cells. This group gives B bar D bar. Thereby we get the final simplified expression as F equal to A plus B bar C bar plus B bar D bar. How many Boolean functions of degree n are self-dual? The answer is option B, 2 power n minus 1. Please check our video regarding self-dual Boolean functions for more understanding. The dual of a Boolean expression is obtained by interchanging Boolean sums and Boolean products and interchanging zeros and ones. Dual of the Boolean expression A into B plus C equal to A dot B plus A dot C is option C, A plus B dot C equals A plus B into A plus C. The dual of a Boolean function is derived by replacing ands with ors and vice versa. For duality, the variables or literals will remain as such. In this expression, the left-hand side A dot B plus C becomes A plus B dot C by replacing ands with ors and vice versa. The right-hand side of the expression becomes A plus B into A plus C, again by replacing ands with ors and vice versa. The Boolean expression AB plus AB bar plus A bar C plus AC is unaffected by the value of the Boolean variable. The answer is option B, B. First, simplify the given Boolean expression using Boolean laws. According to complement law, b plus b bar and a plus a bar become 1. So, the final simplified expression is a plus c. Since this expression does not involve the variable b, it means the given expression is unaffected by the variable b. How many different Boolean functions of degree n are there? This is a thing to be remembered always. There are 2 power n different Boolean functions of degree n. Find the Boolean expression for the logic circuit shown below. It is option A, AB. Let's check out how to derive it. First, let us find the Boolean expression for the logic circuit. Then we would simplify the expression. The NAND gate with inputs A and B gives the output A dot B bar. The NOR gate with inputs A bar and B gives the output A bar plus B the whole bar. The NOR gate output with these 2 inputs gives the output A dot B bar plus A bar plus B the whole bar. Now let's simplify the expression. First, the complement terms are simplified using De Morgan's law A dot B bar equals A bar plus B bar. Again applying the De Morgan's law A plus B bar equals A bar dot B bar to A bar plus B the whole bar makes the expression A double bar dot B bar. Do not forget to include the whole bar, we have not yet reduced it. Applying the appropriate laws at each step, the expression is reduced to A bar plus B bar the whole bar. Now the De Morgan's law A plus B bar equals A bar dot B bar gives us the expression A double bar dot B double bar. With the double negation law, the expression is finally simplified to A dot B. Which Boolean operation on 2 variables can be represented by a single perception layer? The answer is option C, 1, 2 and 3 only, which means the AND operation, OR operation, NOR operation can be represented by a single perception layer. Let's try to understand what does the single perception layer mean. From these truth tables, we could observe that AND, OR, NOR logic gates have truth tables where a single straight line can perfectly separate the true outputs from the false outputs. Whereas in the truth table for the XOR gate, a single straight line cannot be drawn to separate the true outputs from the false outputs. From this, we could also state that the logic gates AND, OR, NOR are linearly separable, whereas the XOR gate is not linearly separable. The minterm expansion of f of p q r equal to pq plus qr bar plus pr bar. The answer is option A, M2 plus M4 plus M6 plus M7. Let's check out how to find it. The expression is given in standard SOP form. We need to first convert the given SOP expression into its canonical form. Then use the truth table to find the corresponding minterms. Please check our previous videos for detailed explanation about canonical and standard forms of SOP and POS. As the first step, let us convert the given standard SOP expression into its canonical form. In a standard SOP expression, each product term does not include all the literals. So first, find the total number of literals involved in the expression. Here in this expression, 3 literals are involved, P, Q and R. Now find the variables absent in each product term. In the first product term, R is missing. In the second product term, P is missing. And in the third product term, little q is missing. Now multiply each product term by the sum of its missing variable and its complement. The expression is then written as PQ into R plus R bar plus P bar into Q R bar plus P into Q plus Q bar into R bar. Combine all the terms in the next step. The expression now becomes PQR plus PQR bar plus PQR bar plus P bar QR bar plus PQR bar plus PQ bar R bar. Cancel out recurrent terms, making the final expression PQR plus PQR bar plus P bar QR bar plus PQ bar R bar. This is the final canonical SOP expression. Now with the canonical SOP expression, use truth table to find the minterm entries. For the first product term PQR, the input values are taken as P equals 1, Q equals 1 and R equals 1. So enter 1 in the corresponding truth table entry. Similarly, for the second product term PQR bar, the input values are P equals 1, Q equals 1 and R equals 0. Make an entry 1 in the corresponding output value F. Again, for the next product term P bar QR bar, P equals 0, Q equals 1 and R equals 0. So enter 1 in the corresponding field. And finally, for the product term PQ bar R bar, the input values are P equals 1, Q equals 0 and R equals 0. Enter 1 as output value for the corresponding truth table entry. Now mark the minterm representations as M0, M1, M2, etc. up to M7. Pick out the minterm entries for which the output value is 1. Thereby the output becomes F equal to M2 plus M4 plus M6 plus M7, which is the simplified sum of products expression for the Boolean function F equal to M0 plus M2 plus M3 plus M5. The answer is option B, A bar C bar plus A bar B plus A B bar C. This problem could easily be solved using K-map simplification. Place ones in blocks of K-map respective to the minterms. Do not forget the order in which the K-map cells are to be filled. Make groups of cells containing ones. We first get this pair by wrapping around the K-map. In this pair, B bar get cancelled, thereby the term A bar C bar gets into the final expression. Then we make this pair where C bar get cancelled, resulting in term A bar B. Finally, as this one could not be grouped anywhere, we keep it as group of one cell, thereby getting the term A, B bar, C. Summing up all final terms gives us the simplified expression A bar, C bar plus A bar, B plus A, B bar, C. Consider these Boolean equations. We need to find which of these two expressions could be proved true. The answer is option C, both 1 and 2 are true. Let's check out how it is proved. Let us take the left hand side of the first expression. It is wx plus w into x plus y plus x into x plus y. Applying the distributive law, multiply the term outside the bracket with each term inside the bracket. Now the expression becomes wx plus wy plus xx plus xy. Applying idempotent law, cancel out the recurrent terms. That is, wx plus wx can be replaced with a single wx. Now the expression becomes wx plus wy plus x plus xy. Take out the common term x and write 1 plus y within brackets. Annulment law makes 1 plus y equals 1. Again, take out the common term x and write 1 plus w within brackets, which again becomes equal to 1 according to annulment law. Thereby, we get the final simplified expression as x plus wy, which is the right hand side RHS of the given expression. So, we could conclude that the first expression is proved to be true. We consider the left hand side of the second expression given in the question. It is wx bar into y plus xz bar plus w bar x bar into y. Follow these steps applying the Boolean laws. Finally, we get the simplified expression as x bar y, which is the RHS of the given expression. We could conclude that the second expression is also proved to be true. Thereby, in the question, both the first and the second expressions are true. Okay, then it's done for today. Hope this video would have helped you sort out competitive exam multiple choice questions related to Boolean algebra. Give this video a like as a symbol of compliment for our efforts. Please do not forget to subscribe to our channel for more such informative computer tutorials. Hit the bell icon for sure. Thank you for watching.